Hi, Ms. Torres. Okay, this is the chapter 3-6 to 3-9 test corrections. So for the first number, we have find dy for y equals x to the third power times sine 2x. So to find dy, basically that's just the derivative. So we'll take this down to dy, and then we take the derivative of this equation. So this is basically two parts to it. So we're going to be using product rule. So for the first part, we're just going to we'll take the derivative of the first part of this. So it's 3x squared times, and then just the regular part, 2x, plus this x cubed right here, and then you take the derivative of the second part, which will give you the derivative of sine is cosine, and since there's this 2x here, you keep the 2x here, and then since there is this 2x here, it's basically like the inside part, so you took the derivative of the outside, and then you also have to take the derivative of the inside, and the inside derivative of 2x is just 2. And then when you break it down here, from here, you can take out an x squared. And then on the inside from here, you'd still have 3 sine 2x. Plus from here, you'd have 2, because you bring this 2 up here, 2x times cos 2x. And then you can't really go anywhere from here, so this is your final answer. Okay, so for this problem, we have to write the equation of the tangent line approximation for this equation. So since it's the approximation, how I do it is I first take the derivative of this equation. So we have f of x equals cube root of 227 minus x. So the derivative, because this equals 27 minus x to the 1/3 power. So the derivative would be 1/3 times 27 minus x to the negative 2/3 power, because you have to reduce this exponent by 1. And then multiply it by what the derivative of the inside is, which is just negative 1 from the negative x. From this part, you go ahead and you plug in the x value that is given, because you're trying to find the slope of the tangent line. So from here, you plug in 0, because that's what they give you for x. And then you do 27 minus 0, the negative 2/3 power. It's all still multiplied by negative 1. And when you break this down, it's negative 1. And then since this is a negative 2/3 power, I'm going to bring it to the denominator. So this 3 stays here, and then multiplied by the cubed, and then the inside, since it's 2 here, is 2 like this. From here we go 1 over 3, and then 27 squared is 729, and then cubed root. When you calculate that, you get 9. So then this gives you m, which is the slope. So m equals negative 1 over 27. And then from here, what you can do is you have m now, and then to get the tangent line equation, you need to fill out the equation y minus y1 equals m x minus x1. So currently we have m, and we have x here, but now we need to find the y value. So to find the y value, you take this x value and you plug it back into the original equation. So f of 0 equals this minus 0, this equals 3. So now you have y equals 3. So down here for this equation, you have y minus 3 equals, and then m we had was negative 1 over 27, x minus, and then x is given as 0. And when you multiply this all out, you get negative, when you distribute this, you get negative 127x, and then this will just be positive 0. And then you add this 3 over, so then plus 3. So then the equation you get is negative 1 over 27x plus 3. Then the second part of the question says, then use t of x, which is the tangent line approximation we found, to approximate this value. So from here, we're going to use the equation that we got. So y equals negative 127x plus 3. And for x, we're going to plug in this value here. So y equals negative 1 over 27 times 26.75 plus 3, which gives you 2.0093. And then that's your approximation. For this problem, we're calculating the percent error. So with percent error, basically what you need to, your goal here is to find both the relative value and the real value of the shape that you're working with, and then that will give you your percent error. So here, the information that we're already given is that the radius equals 40 centimeters long. And then the error in the measurement of the radius, which we'll write as dr, equals 0.2 centimeters. So with this, we have a circular disc. So since we're working with area, we're going to use the area of a circle, which is area equals pi r squared. And then from here, to find the real, we plug in the information that we have. So we have area equals pi times 40 squared. And then this gives you 50, or 5,026.55. And then you go this way to find the relative value. And to do that, you have to take the derivative. So the derivative of the area is 2 pi r dr. And then we start to plug in the information we have here from what we have given. So the relative area is 2 pi, the radius is 40, and then dr is 0.02. When you calculate this out, you will get 50.27. So we take the relative value and the real value, and we use this equation right here. So we divide the relative by the real. And then when you calculate this out, you'll get 0.01. And then another part of the percent error part is, since this is the decimal version, so you need to multiply this by 100 to make it the percent version. So the answer is there's a 1% error. When using differentials to approximate a value, we have two steps. We use dy over dx, and then later, once we found dy, we plug that into dy plus f of x. So originally, since we're approximating, the information we can get or will use from this will be that we find the number closest to this amount and use that for x, since this is an approximation. So the number closest would be 8, and then the change in this from the actual number is 0.05. And then the equation we're going to use when doing dy over dx is going to be y equals x to 2/3, because this is the equation that basically 8.05 acts as x here, and then the 2/3 from this equation is used here. So now we use this, and to do dy over dx, we have to take the derivative of this. So what we do is dy over dx equals, and then 2/3 x minus 1/3. Oh. And then that's that. And then since we're finding dy, we multiply the dx to both sides. And then from here, we can start plugging in the information we have. So 2/3 x negative 1/3 times dx. So dx we know is 0.05. 0.05, and then x we have as 8. So dy equals 2/3, and since this is a negative 1/3, we can take it to the denominator. So cube root of 8 times 0.05. Then from here, we can reduce this to 2/3, and then this gives you the value of 3. So we have 2/9 times 0.05. Oh wait, this is actually, sorry, my bad. This is actually 2. So this is 6. And this is basically what you can reduce this down to 1/3 times 0.05. And then once you calculate this out, like this part, you get 0.01, and then 666 continues on. And then this value is dy. So you use this to plug it back into this step 2. So dy is 0.016667 plus f of x. So we have x equals 8, so we plug in 8 into the original equation. So y equals 8 to 2/3, which is 8 squared. This gives you 64. When you do the cube root of that, you get 4. So you add that to 4. And then the final answer from this is 4.01667. And that gives you the approximation of this. Okay, so for these types of problems, again, since it's a word problem, it's best to draw a picture for these. So the information that we're given in the problem is find the dimensions of the rectangle of the largest area that can be inscribed in an equilateral triangle of side length 10 if one side of the rectangle lies at the base of the triangle. So we have our triangle, and from here each side is 10 since it's an equilateral triangle, and then we have our rectangle inscribed inside. Okay, so if you divide the triangle in half, you'll be dividing the rectangle in half as well. So then the bottom of the rectangle, since it's on the bottom of the triangle as well, can be split up into 2 x's, and then the sides will be y. Since this whole thing is 10, this and this is x, like this one part is x, then this part, since this is half of 10, it's 5, will be 5 minus x. That's this value. And then since the angle here is 60, you divide it in half. This will be 30, this angle will be 60, and this is 90, so it's a 30, 60, 90 triangle. With 30, 60, 90 triangles, so this is 90, this is